All right, guys, this lesson is factoring and it's slightly harder, but I do want to review a little bit from the previous video. So here's one problem from the previous video. Now, if you remember, we have a trinomial that we are going to factor into two binomials. And since this is x squared, we know it has to be x times x. So we're just looking for the missing numbers right here. And we need two numbers that multiply to give us 16, a positive 16. And when you add them, you get negative 10. Now, two numbers that pop into my head immediately are 2 times 8. And 2 times 8, they do give me 16, but do they add up to negative 10? And no, they add up to positive 10. So I can't use 2 and 8. But what if I used negative 2 and negative 8? Well, doesn't negative 2 times negative 8 give me positive 16? And when you add them, they give you negative 10. So I can't use the positive versions, but I can use the negative versions. So I'm going to plug them in. And again, negative 2 and negative 8, it doesn't matter. You can write x minus 8 first and x minus 2 second. So either one of these two answers would be fine with me. All right, now number 2 is basically the same problem, except this number right here in front of the x squared. This is what makes it different from the other problems. So what I'm going to do first is I'm going to try to factor out something from all three terms right here so that it looks like problem number 1. Now, I'm going to look and I'm going to say 5, 35, and 30. I'm going to ask myself, what's the largest number that goes into 5, 35, and 30? What's the greatest common factor? And in my head, 5 goes into all of them. So if 5 goes into all of them, I can take 5 out of all of them. So I'm going to factor out a 5. And 5 times x squared gives me the 5x squared above. And 5 times the negative 35x, or 5 times 7x, gives me the negative 35x up there. And 5 times 6 gives me the 30 up there. So here is my answer when I factored out a 5. Now, if you look just inside the parentheses, that should look very similar to question number 1. So I'm going to now do it just like question number 1. The only difference is I have to keep this 5 on the outside. He is now part of our answer, but he's just not part of either one of the binomials. He's on the outside getting multiplied. So again, I'm going to look and I'm going to say, well, what two numbers multiply to give me positive 6? And when you add them, you get negative 7. And if you're pretty good at these by now, you just realize that 6 times 1 would add to 7, but I need it to be a negative 7. So I would say a negative 6 and a negative 1. Negative and negative multiplies to give me positive 6, and they add to give me a negative 7. So this is my answer. I just had to factor out a number 5 first. Let's go to number 3. Again, this number right here makes it different from all the other problems we've done. So I'm going to look and say, well, can I take something out of all three terms? And I say, well, what's the greatest common factor of 3, 9, and 84? Well, you can actually take a 3. 3 goes in all of them. So I'm going to try to factor out a 3. So 3 times b squared gives me the right above it, 3b squared. 3 times negative 3b gives me the negative 9b, and 3 times negative 28 gives me the negative 84. And if you look inside the parentheses, it looks just like problem number 1, so we can solve it the same way. But I have to keep that 3 on the outside, and I'm going to go ahead and set up my two binomials. Now I need two numbers that multiply to give me negative 28, and they combine to give me negative 3. Now to get a negative 28, I need a positive number times a negative number. And I'm going to say 7 and 4. Now, when I do 7 and 4, I need one of them to be negative and one to be positive. So if I start off with positive 7 and negative 4, that combines to give me a positive 3, and I need a negative 3, so it can't be that. So then I would try negative 7 and positive 4, and that combines to give me negative 3, and that's exactly what I needed. So I'm going to plug in a negative 7 and a positive 4. And again, it doesn't matter which place you put it in as long as it's negative and positive, negative 7 and positive 4. All right, again, the number 4, this 4 right here is what makes this problem more difficult. If that was a 1, it would be like question number 1. So we're going to look and try to factor out a number 4. So I'm going to go ahead and set it up. And then 4 times n squared gives me the 4n squared right above it. 4 times 4n gives me the 16n right above it. And 4 times 45, negative 45, gives me the negative 180 right above it. Now I factored out a 4, and inside looks just like question number 1, so I can solve it the same, but I have to keep that 4 on the outside. So now I need two numbers that multiply to give me negative 45, but when I add them, I get positive 4. So the numbers that pop up to me real quickly are 5 times 9. So I'm going to say 5 times 9. And to get negative 45, I need one of them to be a negative. So I'm going to start off with negative 9 and positive 5. And that combines to give me a negative 4. But I need a positive 4, so I can't use those. So now I'm going to think positive 9 and negative 5. And those two combine to give me a positive 4 that I need. So I need positive 9 and negative 5. And that's my answer to this one.